Let's see some of the problems related to equivalences. Okay, so most of the time they ask two kinds of questions. One is given two formulas, how to relate them, are they equivalent or not. Second one, they give you a formula and they ask whether simplify it, they ask you to reduce it. For any of the problems, any kind of problems, you should know equivalence rules. So already I taught you equivalence rules in the previous video. Please go through that video and understand all the equivalence rules and remember them and come back and try to answer this question. So P or Q implies R equivalent to P implies R or Q implies R. How to solve this problem? Method number one, directly I am using equivalence rules and I am going to simplify this equation and this equation. Later on I compare them. Let me simplify equation 1 and equation 2 one by one. Let's do this one first. P or Q implies R. Whenever I see implication, better try to remove it. We have a structure A implies B, isn't it? Whenever you have A implies B, always I can replace it with negation A or B. Okay, so this rule I use. If I use it, then P or Q will become A, this will become B, and A implies B is nothing but negation A, negation of P or Q, or B. B is nothing but R. Now after that, whenever you have negation of some unit, then that has more priority, correct or not? That means you have to target this one first. Then while targeting this one, you realize that there is a De Morgan's law, correct or not? Using the De Morgan's law, we can expand it if you want. Then it will become negation P and negation Q. In that way, we can open this brace R. Now, one small hint I would like to give you. Whenever you have an equation with all the distinct variables or different variables, that formula cannot be further simplified. You stop it. Okay, so we can't further simplify it. Let's leave it. Now go to the second part of the formula, that is P implies R or Q implies R. The first step, as usual, remove implication. Then you get negation P R or Q implies R is nothing but negation Q R, isn't it? Now the next step, all are R operators, isn't it? Then we can open the braces. We can write directly negation P R or negation Q R, isn't it? Now my target is, there are two variables with same name called R. I would like to simplify them. So for that we have a rule called R is R, but they are not together, right? We have to somehow bring them together. For that I use commutative rule. So recall, commutative rule is negation Q R equivalent to R negation Q. Please remember, whenever you replace a formula with another formula, they should be equivalent. That means their behavior should be same. Otherwise, please don't replace. Okay. So before replacing, always ensure that the formula which is replaced is equivalent to the new one. Now negation P R. Let me copy as it is, negation P R. Now we can simplify it. It will become negation P R is R negation Q, isn't it? Why I am applying this R before other R's? Because associative rule. The associative rule says when you have multiple R's, any rule, any R can be applied first, correct? That's why happily I can apply first this R. Now if I apply that, you get negation P R negation Q. Since R is associative, one more thing, see now negation P and negation Q R is one thing. Here you got negation P R negation Q. Again let me swap R comma negation Q. Yes, we can use commutative rule for that. Then you get negation Q R. Okay, now observe these two formulas. We have R, right? R, and we have remaining formula as negation P and negation Q, but here we have negation P or negation Q. Are they equivalent? No, right? So R something, but that something and something are not equivalent. Then these two formulas cannot be equivalent, isn't it? That's why this equivalent is wrong. You understand that? Now same thing we do with method number 2. In this method number 2, rather than taking this traditional technique of replacing with equivalence formulas, I use another technique, that is substitution. I will try to reduce the variables by taking one variable and substituting that value, once true and once false. Let me do that. In this formula, let me choose R and let me target that. First time I keep R value true, second time I keep R value false. Really these two formulas are equivalent. When R value true they should be equivalent, and when R value false also they should be equivalent. That's it. So let me try that. PRQ implies R. I am substituting R value true, right? Then it will become PRQ implies R is now true is equivalent to P implies R value true or Q implies true, isn't it? Q implies true. If PRQ is true, true implies to true. PRQ is false, false implies to true, isn't it? What I want to say is, irrespective of PRQ value, then overall formula this will become true, isn't it? That's why this is simplified to true. False implies to true, true implies to true, then it's not at all depending on PRQ value, isn't it? That's why it is true. Is it equivalent to? Here also same concept I can apply. When in implication formula, when you have implication and right side is true, automatically overall formula will become true, because whatever you apply, p value, example p value true, then also true, p value false, even that value also gives you overall true, right? So that's why overall is true, or q implies true. Same concept, then here also you get true. True or true? True. So finally you got true and true, isn't it? That means these two formulas are equivalent when R value true. But that doesn't mean that they are always equivalent, correct? We have to take one more case where R equal to false. Let's try that. If R equal to false, then your equation will become PRQ implies false, isn't it? It is left side. And right side formula will become P implies false or Q implies false. Okay. Now again we use same reasoning. Let's take PRQ as something. This something is true. True implies false. False. Remember, if PRQ is true, then overall formula is becoming false. If PRQ is false, then false implies false is true. So I can say that this entire formula is exactly, exactly behaving oppositely, isn't it? That means this formula is exactly opposite to PRQ, right? If PRQ is true, overall false, PRQ false, overall true. It's exactly opposite to PRQ. I can say it is opposite, that means negation of PRQ, isn't it? Remember it. So that is a truth value of this PRQ implies false. With the same concept, I can say P implies false truth value depends on exactly negation P, correct? The reason, forget about other component. If P equal to true, true implies false, false. That means, it's opposite to P. If P value false, then false implies false true. Still again it's opposite to P's truth value. That's why I said negation of P. Or Q implies false. Again it will become negation Q. Now we have negation of PRQ, negation P and negation Q. Right side negation P or negation Q. Are they equivalent? No, they are not equivalent, because we have AND symbol here, we have R symbol with same parameters. Then they cannot be same. With this model, now I can say that these two formulas are not equivalent when R value false. So overall they are not equivalent. Let's take second problem. Negation of P double implies Q is equivalent to P double implies negation Q. Is it true? Are they equivalent? We'll see. Method number 1. This time I use substitution technique. Since there are only two variables, right? Let's target first P as true. Really these two formulas are equivalent. When P equal to true, they should be equivalent. And when P value false also, they should be equivalent. It's that simple. Okay. Now let's try with P value true. Let me reason when P value true. Negation of true double implies Q is left side, and right side it will be, I am substituting P value true. True double implies negation Q. Are they equivalent? We'll see. Now just observe Q's values. Like let's observe Q values. When Q value true, true double implies to true. And when Q value false, true double implies false, false. Can I say one thing? So this entire truth value of this entire formula is depending on Q, correct? When Q is true, overall true, Q is false, overall false. That's why I can replace this equation with Q. That's why this will become negation q. Now come to here. This is, let's say, something. If something is true, overall true, true double implies true. If that something is false, then true double implies false is false. Again, this entire equation is depending on the right side. So that right side is nothing but negation q this time. You understand that? So finally, when p value true, left side is giving negation q, right side also effectively giving negation q, and they are equivalent. But that's not sufficient, isn't it? Because only you substituted p value true. Really these two equations are correct. They should be correct when p value true, and they should be correct when p value false. That's why let me try p value false also. Then negation of false double implies q. At one side, is it equivalent to false double implication negation q? Let's try that. Again, same reasoning. False double implies true. Let's take this something as true. Okay. If this something is true, then false double implies true is false. Remember it. Now this something is false, then false double implies false is true. If you carefully observe, this entire expression's truth value is depending on q, definitely, because when q value true you are getting some value, and when q value false you are getting some different answer, isn't it? That's why I can say that this expression is depending on q. But how it is depending? When q value true, false. When q value false, true. Is it not opposite? That's why this entire expression's truth value is depending on q, but not direct, indirect. That means it's exactly opposite to q. So that's why it is negation q. Now we have this negation. Let's write it. Negation of negation q, which is nothing but q. Now go to right side. Let's do the same logic. We know that this something, let's take as something, that something is true, then overall formula false. The reason? False double implication true, false. If that something is false, then false double implication false true. Now this entire equation's truth value depending on that something, isn't it? Is it not opposite to this negation q? Yes, opposite to negation q is nothing but negation of negation q, which is nothing but q. This formula is exactly depending on q, and exactly it is q, and this formula also q when p value false. Now let's summarize it. When p value true, they were same. When p value false, also they were same. That's it. They are finally equivalent in every case, right? We tried all cases of p. For all cases of p, these two equations are correct. Let's go to second method. In the second method, what I do is I use truth table. That means since there are only two variables, isn't it? Then drawing truth table is not a big deal. Let me draw the truth table for two equations. One is negation of this, this formula and this formula. Let's draw the truth table very quickly. So truth table will be like this. I want p variable and q variable, isn't it? Then what are the behaviors they all together can have? True, 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 false, false, true, false, false, isn't it? Now we have to check p double implies q first, right? So systematically I will come to negation of p double implies q. Before that, let me do p double implies q, that is true, false, false and true. Truth table of double implication. Then go to negation of p double implies q, which is nothing but opposite of p double implies q. It will become false, true, true, false. This is very easy technique. Second one, p double implies negation q. For that you need negation q. Let's take negation q. Whenever these are the q values, negation q will become false, true, false, true. The reason negation q is quite opposite to q. That's why I constructed negation q now. We need p double implies negation q, isn't it? This is final one. We have, this is p, this is negation q. Apply double implication. True double implies false is false. True double implies true is true. False double implies false true, and false double implies true is false. So this is the truth table of p double implies negation q. Now observe the false, true, true, false, and p double implies negation q, false, true, true, false. They have identical values, then they are equivalent. In that way, so using truth tables also we can solve the problem sometimes. Okay, but generally you do one thing. Whenever you have very less variables, like one variable or two variables, go for truth table. The reason, when the number of variables are more than 2, then the number of entries in truth table will become exponential. They will become large, and it will take a lot of time. When there are 3 variables, you will have 2 cube rows, that means 8 rows. Then calculations will become lengthy and it takes a lot of time. Okay, that's not suggestible. Whenever you have 3 variables, better go for substitution technique, which I taught you. Okay, so in that way you can solve questions related to equivalences. Let's look into some more problems. P and Q implies PRQ is equivalent to true, false, P and Q, PRQ. So we can use multiple techniques. One technique is you can substitute P value true. You can target P and you can substitute P value true and P value false. And whenever P value true, substitute in the options also P value true and match the truth value of the problem. Second one, take P value false and again substitute in the options P value false and try to match the appropriate one. That's one idea. The second idea, usual technique, applying all the equivalence rules appropriately. Okay, so let's use that method. I use equivalences and I try to solve it this time. So P and Q implies PRQ, right? According to priorities, and versus implication, and has priority. Implication versus R has priority. Then your formula will be converted like this. This is equivalent to, whenever I remove implication, it will become negation of P and Q or PRQ, isn't it? So please note down, A implies B is nothing but negation A or B. This is the formula I'm using. So now second step, you have P's and Q's and P's and Q's, but these P's and Q's are locked using negation. Try to release it. That's a common sense. If I can release it, then probably they can become mobile and they can go to other places and probably formula can be simplified. So that's why what comes to my mind immediately is releasing this one. I use De Morgan's law to release it. Then it will be negation of P and Q is nothing but negation P or negation Q and R PRQ. Since R all are R operators which are associative, I can remove the priority braces. Like you end up with the without braces, isn't it? Now my target is, I have a variable with P and negation P, isn't it? I want to combine them. I want to bring them together so that they will be cancelled. Okay, please recall equivalence rules, then you realize that PR negation P is true and P and negation P is false. In that way, anyhow, so the variables, if with P and any variable with its true form and its complement form comes together, they will be cancelled and you get simplest form. That's my target, but you have negation P here, P here. How to bring them together? Commutative rule will swap the elements and it makes the distance lesser, correct or not? So for that I'll do like this. I use commutative rule here, right? So negation P R, negation Q R P can be written as P R negation Q R Q. Surprisingly, P and negation P came together and negation Q R Q came together, correct? So finally it will become PR negation P. Since R's are associative, any order we can apply, then let me apply PR negation P true or QR negation Q true. True or true is nothing but true. Finally, this problem is simplified to true. That means your formula is equivalent to true. Let's see one more problem. P and P implies Q is equivalent to. Okay, same technique. First I take the formula P and P implies Q. There are multiple implications. We have to remove them one by one. Okay, first see the priorities. And versus implication, which has priority and, that's why this formula is like this. Okay, let's solve this unit first. Let me simplify this unit first. Okay, so P and P implies Q, that will become P, and we know whenever we have implication we can write negation P R Q, isn't it? So this is the entire unit, implication Q. Let's solve this implication later on. Before that, let me complete this one so that I get simplified form. So P and negation PRQ, same concept. When P and negation P are the variables, if you can bring them together, they will cancel each other, right? To do that, directly, some students ask this question like this: why not we directly take P and negation P and cancel? Then priority rules will not accept. Since now R is in the brace, right? So because already in the problem it is braces are given, then R got now new priority. Initial, naturally, AND has more priority, we know that. But if braces are given for any operator, that will get ultimate priority. Okay, we have to follow that. Since R has now more priority than AND, we can't take P and negation P together, so that's not possible. Then try to think other alternatives to bring them together. So what is striking to me is, De Morgan's law, right? So, sorry, distributive rule. Whenever you distribute AND over R, then P and negation P comes together. You see, P and negation P are Q is nothing but P and negation P. I'm using distributive rule. Remember it. P and negation P are P and Q. P and Q. Okay. So this is a simplification part. Now, P and negation P, please recall equivalence rules, and there is a rule called domination rule, cancellation rule. So that will cancel P and negation P. So P and negation P will become false. So false are P and Q. Okay. So we have P and negation P as false. Please recall that previous rules, equivalence rules. There, otherwise, that's why I told you, without remembering that all that equivalence rules, you can't solve this problem. Okay, at least you do one thing. Whenever you are watching this video, take the printout of that all the equivalence rules and keep with you, and please observe them while watching the video. Okay, so there is a rule with P and negation P. Please look into that paper. P and negation P is false. Okay, false are P and Q. That implies Q. Now, what is my idea is, false are something. How I simplify, you see, false or true is true, false or false is false. Is it not depending on the right component? False or something will become something. The reason false or true, true, false or false, false. That's why it is depending on P and Q, and that's a straight dependency, correct or not? So if this is true, true, this is false, false. That's why P and Q. P and Q implies Q. We have equivalence rule also that says that false are something, like false or P is P. Just recall the rules. Now P and Q implies Q. Again, try to remove this implication. Then further formula is negation of P and Q, negation of first component or second component. Now negation of first component is nothing but negation P or negation Q. I am applying De Morgan's rule. The reason, same concept. You have Q here, you have Q here. If they come together, they they will simplify each other. But before that, it is locked with negation. Open it. Then negation P or negation Q or Q. Since R is associative, anything we can apply first. Let me apply this one first. Then you get Q or negation Q as true, isn't it? Now negation P or true. So now again same logic we apply. True or true, true. True or false, true. That means it's not depending on the other component. That's why this formula is nothing but true. Overall it is true, correct? It's not at all depending on this one. So answer true. In that way we can say that this formula is nothing but true. Okay, in that way, so we can solve questions related to equivalences. Let's solve some gate question here. In gate 2002, this question is asked, if x then y unless z is represented by which of the following formulas? They have given 4 formulas. So to understand this problem, you should know first how to use unless in English. Okay, that's why for that I give you some English statement. The structure of that English statement should be A unless B, isn't it? Let's take that. It's like this. I eat ice cream always. I eat ice cream always unless it rains. If it rains, I don't know what I do. I'm not sure. Generally I eat ice cream ever, always, unless it rains. If it rains, I can't give any guarantee about my behavior. If you ensure there is no rain, then I ensure I eat loads of ice creams. That's what this statement. Understand that. If it doesn't rain, then definitely I do this regular activity called eating ice cream. Okay, so that means finally, if it does not rain, that means not of B. Let's take this as B, this as A, then not of B. If you ensure that, then I can promise you a ice cream party where I eat lot of ice cream. That means I eat ice cream. So negation B implies A. From now onwards, whenever I have A unless B, I write negation B implies A. Let's convert this problem. We have X then Y unless Z, isn't it? Then X then Y, if X then Y unless Z, unless Z. Now this is already X implies Y, correct? So X implies Y unless Z. A unless B is nothing but negation B implies A. Then here also we have A unless Z. A unless Z is nothing but negation Z implies first component. First component is X implies Y. So this will become negation Z implies X implies Y. But if you see the options, nothing, no option matches with this one. What to do then? Here, equivalences are, simplification plays important role. What I do is I take this one and I simplify it, and I take the options and I simplify them, then I will see. So something definitely will match with the this equation. Let's try that. Let's simplify this one first. So this is like A implies B, correct? Whenever you have A implies B, it will be negation A or B, isn't it? Negation of A is nothing but negation Z or B. B is nothing but X implies Y. Now negation of negation Z is Z, isn't it? Or X implies Y, you might know that negation X or Y, isn't it? Finally this becomes Z or negation X or Y. Since all are R operators, they will become Z or negation X or Y. You remember this equation. Why I am stopping here? Why I am not further simplifying the reason? You have a variable with Y and one variable with X, one variable with Z, right? So this kind of equations cannot be further simplified. Now go to the options. Let's take option number A and let me simplify it. That is X and negation Z implies Y, correct? Here I do. So it's like again A implies B structure, then that is nothing but negation A, that is negation of X and negation Z, or B. B is nothing but Y. Let's simplify this part. De Morgan's law. Negation of X and negation Z is nothing but negation X or negation of this component. That is nothing but negation of negation Z. Z. So that will become negation X or Z or Y. Now again R operators are associative, then we can remove them, then you get negation X or Z or Y. Okay. Here also negation X or Y or Z. Here also negation X or Y or Z, right? So both are equivalent. That's the reason option A is the right choice. In that way you can answer any gate question. Okay, believe me. Let's see one more problem. The binary operation is defined as follows: P, Q and P box Q. So how we defined is when P true, Q true, it is true. When P true, Q false, it is true. P false, Q true, it is false. P false, Q false, it is true. Okay. Now they are asking about PRQ. Which one of the following is equivalent to PRQ? We have to identify one of the option. Which one is equivalent to PRQ? Okay. It's so simple. Now let's carefully observe what is P box Q, because this entire concept depends on box operator, isn't it? If you understand box operator clearly, you can answer it. It's that simple. P box Q. So it's not a new operator. If you closely watch, when P true, Q true, it is true. When Q false, P true, it is true. See now, it's like implication. True implies to true, false implies to true, true implies false false, false implies false true, isn't it? It's exactly implication operator, but it's from Q to P, not P to Q. That's it. So now I realize that P box Q is nothing but Q implies P. From now onwards, whenever I see box, I can replace with implication. Once I convert my problem to implication problem, then I can replace implication by R operator, correct? That's what my idea. Let me use it. Okay, let's take options one by one. If some option is correct, that should be simplified to PRQ. Remember it. Let's begin with A. Negation Q imply box negation P. We know that P box Q is nothing but Q implies P. That means second term implication first term. Okay, this is second term negation P, implication first term negation Q. After that, we know how to simplify it, isn't it? A implies B is nothing but negation A or B. So negation A is nothing but first component. This is A implies B, right? A implies B is equivalent to negation A or B. So here in the place of A we have negation P, isn't it? Or B, in the place of B we have negation Q. Then if you simplify it, negation of negation P or negation Q. That's false. Right? We have to get P or Q. Let's take option B and let's do the same thing. P box negation Q. The first step is equivalent to, second term implication first term. Second term implication first term. Next step. Whenever you have implication, we know that A implies B is nothing but negation A or B. Then here negation A is nothing but first term negation Q or B. B is nothing but second term P. Then it will become negation of negation Q, which is nothing but Q or P. So nothing but P or Q, since R is commutative. So finally this option is giving you P or Q. That's why option B is correct. In that way easily you can answer this kind of questions. We will see one more problem which is asked in GATE 2006. Consider the following statements. One is P1 some formula is given. One more statement which is again another formula. The question, which of the following is tautology? Okay, so the formula is very complex, right? And doesn't matter whatever maybe it is. If someone says P1 is tautology, then the formula should be always true. Okay, let's take the formula. What is that formula? The formula is A and B implies C is equivalent to, this is symbol for equivalent, okay, implies equivalent to A implies C and B implies C. So this is the statement. If it is tautology, then it should be always true. Okay, this entire thing is always true. If this entire thing is always true, then formula 1, let's say it is formula 1, this is formula 2. The equivalence between two formulas should be always true. That means these two formulas are equivalent. What if they are not equivalent? If formula 1, formula 2 are not equivalent, saying that they are equivalent is false, then this entire statement is false, but tautology cannot be false. Correct? So finally our problem is reduced to checking whether these two formulas are equivalent or not. Okay, let's check whether these two formulas are equivalent or not. Okay, we have our method. Let's take this method like substitution method. Let's take C value true and observe left hand side and right hand side. Okay, let's take C value true. If I take C value true, then the resultant equation will become A and B implies true, isn't it? And right hand side will become A implies true and B implies true. Okay, are they equal or not? We'll see. We know that when you have implication, whatever you keep at left side, then overall formula will be true, isn't it? Because if A and B is true, let's say, if A and B is true, true implies to true. If A and B false, false implies to true. Already we have discussed this in the previous session, isn't it? So finally, this is not depending on A and B. So overall formula is not depending on A and B, automatically it is becoming true. That's why note down that LHS is true now when C is true. Now come to this right hand side. A implies C, which is nothing but A implies true and B implies true, isn't it? Now with the same idea, when right hand side true for any implication, then overall formula will become true. Okay, and when here also same structure, then it will become true. Then true and true, true. Perfect. That means these two formulas are equivalent for C value true. But this C value true is not covering all the cases, isn't it? C might be false. When C is false, still these two formulas are equivalent. Then we say that this entire statement is tautology, right? Let's take when C value false. Let's take C value false. When I take C value false, this equation will become A and B implies false, isn't it? And RHS will become A implies false and B implies false. Okay. Now again, when there is implication and implication's right side is false, then this equation's truth value depends on A and B. How it depends, we'll see. When A and B is true, true implies false is false. Just note down the data. When A and B true, overall value is false. When A and B false, then false implies false is true. When A and B false, the overall formula become true. So if you observe A and B true, then overall formula false, A and B false, overall formula true. Is it not exactly opposite to A and B? Isn't it? That means your formula is exactly opposite to A and B. So that how I convey in the expression negation of A and B. Finally, so your answer, this entire expression will be negation of A and B. It is not exactly A and B, it's opposite to A and B. Now similarly, we'll come to this one. A implies F. So with the same logic, whatever I applied here, if I apply it, this will become negation A, isn't it? This truth value of this depends on opposite of A. Truth value of B implies F is exactly equivalent to negation B. So negation B and B implies F has same truth values, isn't it? We already observed. Then negation A and negation B. Now see this. Negation of A and B is nothing but negation A or negation B, and this one negation A and negation B. Are they equivalent? No. That means when C value false, this is becoming A and B whole bar, this is becoming A bar and B bar, which are definitely different, isn't it? That's why these two formulas are not equivalent. When they are not equivalent, then something is true, something is opposite. Like, one component is true, one component might be false. In that way, then true equivalent to false will become false. That's why this overall statement is not tautology. Okay. The second expression is P2, which is nothing but A or B implies C. Is it equivalent to A implies C or B implies C? If they are equivalent, then the corresponding formula will be tautology. So simple, isn't it? Now we'll use same technique. Let's take C value true. When C value true, then what happens? You know that, right? Automatically, irrespective of A or B, this overall formula is true. Let's say LHS is true. When C value true, this formula will become A implies true or B implies true, isn't it? We know that A implies true automatically true. So many times we have seen. B implies true automatically true. So true or true is true. Finally, we prove that when C value true, both expressions have same truth value. But we have to check for C value false also, right? Let me check for C value false. When C value false, then this first expression will become A or B implies false. Okay. So that is nothing but already I taught you that when right side is false, it depends on A or B. If A or B true, true implies false, false, note down. When A or B true, overall value is false. When A or B false, just substitute it. False implies false, true. Then overall expression become true. Now by observing this data, I can say that this entire formula's truth value is false when A or B true. It is true when A or B false. Is it not opposite to A or B? That's why it is opposite negation. That means negation of A or B. Okay. So finally, this is negation of A or B. Now with the same idea, if I substitute C value false, what happens? We'll see. Let's remove here this point. Now A implies false or B implies false. If I substitute false, then A implies false. With the same idea, A implies false will become negation A, or B implies false truth value will become negation B. With the same logic, then you get negation A or negation B. Okay, this is negation of A or B, which is nothing but negation A and negation B. Are they equivalent? No. Again, they are not equivalent. So now I can say that these two formulas are also not equivalent when C value false. That's why these two formulas have different truth values at same time. Then this formula P2 is false. So it is not tautology. So finally I can say that neither P1 nor P2 is tautology. That's why both P1 and P2 are not tautologies is the answer. In that way, very easily you can solve gate questions related to equivalences. Let's see one more problem. Which one of the following logical expressions are equivalent? Okay, they have given 4 statements. We have to identify how many of them are equivalent. Okay, let's begin with first one. So first one is P or negation Q. Already it is in the simplest form, isn't it? we have one variable p, one variable q, then we can't further simplify it, right? Let me keep it as it is. Let's go to second one, negation of negation p and q. Let's simplify it. So first I apply this negation using De Morgan's law. It will become negation of negation p, that is p, or negation of the second component, negation q. So 1 and 2 are equivalent, but still with that knowledge I can't differentiate, options, right? All are having 1 and 2 a common, right? So that's why better go for third statement, which is nothing but p and q, or p and negation q, or negation p and negation q. So what I do is I use a distributive rule here. You see here, a and b or a and c. Whenever you have a and b or a and c, I can write a and b or c, isn't it? The goal of using this one, so why I decided to take distributive rule, I will explain. I have seen q and q bar, right? So little bit apart. I want to bring them together. That's my idea. If I apply distributive rule, then b comma c will come together and they will get cancelled. That's what my idea. That's why I used it. Then it will become p and q are negation q, and r negation p and negation q. Remaining thing is as it is. Now let me simplify it. P and we know that q or negation q is nothing but, according to cancellation, it is tautology, true, right? R negation p and negation q. Now p and true are something. Already I told you, whenever you have AND operator, it has more priority. That's why we have to apply this one first. Then p and true is nothing but, see, p and true. Already if you studied equivalence rules before this video, probably you know that p and true is nothing but p. Okay, so p are negation p and negation q. Now again, we have p and negation p, then we have to bring them together. For that, what comes to my mind is distributive rule. Let me apply distributive rule, that is p are negation p and p are negation q, isn't it? Then p are negation p is nothing but true and p are negation q. So there is a equivalence rule called true and something is something. I use that, then the answer is something, PR negation Q. Yes, surprisingly 3 is also coming to 1 and 2. That means 1, 2, 3 are same. So finally we have fourth statement. Without solving this we cannot answer. The reason, however, option A wrong, because 1, 2, 3 are definitely same. So this option says only 1 and 2. I can eliminate it. Now we have 1 to 4 we can eliminate because we have 3, 2, right? So 3 also might be the 3 also correct answer. That's why now we have option B or option D. Option B says only 1, 2, 3. Option D says all of 1, 2, 3, 4. If 4 is also equivalent to PR negation Q, then answer is D. If 4 is not equivalent to them, then answer is only 1, 2 and 3. So finally it is, we can decide only after evaluating statement 4. Let me evaluate statement 4. So the fourth statement is, let me copy down, fourth one, P and Q or P and negation Q or negation P and Q. If you notice something here, this component, equal, right? So already we have simplified this part and we got first P and Q are negation Q here, then Q are negation Q become true, and after that P and true, after that are negation P and Q. Easily you can check that 4 is not equal to 1, 2, 3 because you have different component here, right? So P and true. So P and true and something, already we know something, are negation P and Q. So now again distributive rule, this time it will become P are negation P and P are Q. That is distributive law. So that will become P are negation P, which is nothing but true, and P are Q. Already I told you true and something is something. That something here is PRQ. You get PRQ, which is not equivalent to PR negation Q, isn't it? So in that way, easily you can check that correct answer is B, right? Only 1, 2 and 3. So if you have concept, then solving gate questions is not a big deal. Okay, just you need practice. And I would like to tell you one more important point. To solve simplification problems, first you should go through that all equivalence rules, okay, and you have to remember them really hardly, like you have to remember each and every point, then it would be easy. Suddenly example, if I say p and true, okay, so p and true, I know that it is p because there is a rule called p and true is equivalent to p. If you don't know that, you can't understand this solution. You understand? That's why always before watching this video, so there is a video of equivalence rules. Please go through it first. After that, come back to this and solve it. Okay.